Okay, I think we are up and ready to rock and roll. Yeah, brother. Yes. Okay, cool. Welcome to another day of lead coding. Let's get this done, guys. So, our goal is to do 10 questions, maybe. Yeah, let's do 10. Fuck it. So, yesterday I was doing linked list. Let's get it going again. Okay. Given an array of integers nums containing n plus 1 integers, where each integer is in the range of 1 to n inclusive, there is only one repeated number in nums. Return this repeated number. You must solve the problem without modifying the array nums and using only constant extra space. Without modifying the array nums and using only constant extra space. Ah. Very nice, very nice. Let's get this bitch to here. So we have this array of integers, and as you can see, the length of this is how much? 5, and the numbers range is 1 to 5 inclusive. But there is a catch, there is one number repeated here. Return this repeated number. So earlier I was thinking like we could use indices at as the caching mechanism. Like if we have seen 1, we can set 1 minus 1th index number as negative, something like that. So negative signs represent that this number has been seen before, so that we can recognize like if you know when a repeated number exists, then we can simply return that. But the point is, without modifying this array, we cannot put negative signs. Interesting. And the point is, this is under linked list. If you take a look here, so most likely we need a linked list, right? Now nums can be, n can be 10 to the power of 5, which is pretty bad. Oh, there is only one repeated number in nums. Return this repeated number. Oh, what? Without any constant extra space. Interesting. So, okay. If I do like some sort of mapping or something, like if I go to 1 minus 1, which is 0, I, uh, yeah. Money and then multiply. What? Yeah, some sort of linking is needed. I don't know, bro. If I'm at here, if I go to 0, I still say it here. I can check if it is a self loop, then move on. Then I'm at here, right? So if I simply take like subtract 1, just to make it clear, what I want to do. Now the numbers here will be the indices. Essentially it won't exceed the indices, right? So there is a self loop here, so we move on. Then I go to 2, 3, 3, 1. Interesting. Hmm. I don't know, bro. I can't. Okay, I have done this question before. Oh, just sort. Yeah, sorting is a thing. Yeah, you must solve the problem without modifying the array and using only constant extra space. Yeah, we can sort that, but we don't want to sort. Yeah, we can't change it. Okay, let's look at this solution. Order of n time and order of one space. This is the most viewed. Let's see. The main idea is the same problem, linked list cycle 2. Let's take a look at this as well. Given the head of a linked list, return the node where the cycle begins. If there is no cycle, return null. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of the node that tail's next pointer is connected to. What? Use two pointers, fast and slow. The fast one goes forward 2 steps at a time, while the slow one goes only 1 step each time. They must meet the same item when slow equals fast. Yeah, in fact, they meet in a circle. The duplicate number must be the entry point of the circle when visiting the array from nums 0. Next, we just need to find the entry point. We use a point, we can use the fast one before to visit from beginning with 1 step each time to do the same job to slow. Okay. Okay, slow is nums of 0, fast is nums of 0. While slow is not equals fast, slow equals nums of slow, fast equals nums of fast. I didn't get it. What? And one thing to notice here is he's not taking any -1 and shit like that. Okay, let's take this code and try to understand. So I'll take a screenshot, paste it here. Right. So what we are trying to do here is, if num size is greater than 1, then slow is nums of 0. Slow is 0. Yeah, let's take this. Slow and fast. Slow is 0. Fast is nums of 0. So nums of 0 is 1 and nums of 1 is 3. Okay. But this could have been 5, right? Yeah. Nums of 5 is out of bounds. How does that work, buddy? Because in the description, oh, containing n plus 1 integers where each integer is in the range of 1 to n. Wow. N plus 1 integers. So If the total number of elements in the nums are 5, then n is 4. Crazy. Okay, so it is already in the index. I don't need to change anything. While slow is not equals fast, slow equals nums of slow. Slow equals nums of slow. Slow equals nums of slow. 0 equals, sorry, slow equals, okay, this becomes 1, right? Fast becomes nums of fast. So nums of 3 is 2, and then nums of 2 is 4, right? Now still they are unequal. Slow becomes nums of slow, so nums of 1 is 3. Nums of fast, nums of 4 is 2, and nums of 2 is 4, right? Nums of 2 is, nums of 4 is 2, nums of 2 is 4. So it's kind of a self loop here, but still let's go. Nums of 3 is 2, this is still 4. Then nums of 2 is 4, this is still 4. Now they are both equal. Then fast becomes 0, this is end of the first loop. While fast is not equal slow, while fast is not equal slow, this is still 4. Fast equals nums of fast, fast equals nums of fast, nums of 0 1. Slow equals nums of slow. Nums of 4 is 2, so this is 2. Nums of 2 is 4, nums of 1 is 3. Nums of this will be 2 again, nums of 3 will be 2. Now these two are equal. Return slow, otherwise return -1. Oh, but why does this work? Why does this work, buddy? Use 2 pointers, the fast and the slow. The fast one goes forward 2 steps at a time, while the slow one goes only 1 step at a time. They must meet the same item when slow equals fast. It means that there is a cycle. In fact, they meet in a circle. The duplicate number must be the entry point of the circle when visiting the array from nums of 0. The duplicate number must be the entry point of the circle when visiting the array from nums of 0. Next, we just need to find the entry point. We use a point, we can use the fast one before to visit from beginning with the 1 step at a time, do the same job to slow. When fast becomes slow, they meet at the entry point of the circle. Let's take a look at some other explanations. Okay. In order to solve this, what question is saying we have given the head of a linked list, return the node where the cycle begins. If there is no cycle, return null. In order to solve this question, we will use Floyd's cycle algorithm, which states that traverse linked list using 2 pointers, move 1 pointer slow by 1 and another pointer fast by 2. If these pointers meet at the same node, then there is a loop. If pointers do not meet, then linked list doesn't have a loop. Now let's understand how we will solve this problem using the above. First, take an example. Yeah, I know this. I mean, I know that when they meet, then there is a circle. Otherwise, there is no circle. But how do we get the entry point, right? Yeah, which shows. But if there is no loop, then fast will move to null. But our focus is on where the cycle has started. So for that, once they meet, slow equals fast, then we will reset the slow back to head. and start moving slow with 1x speed, and fast will carry on from where it was previously but with 1x speed. Yeah. Once slow and fast collab, we will return either slow or fast is the same thing as they will return tail connects to node index 1. Let's do some math. Assume the distance from the head to start of the loop is 1x, x1. The distance from the start of the loop to the point fast and slow meet is x2. The distance from the point fast and slow meet at the start of the loop is x3. Okay, head to the start of the x. Yeah. So what is the distance fast moved? What is the distance slow moved and their relationship? So fast moved x1 plus x2. The distance to the point fast and slow meet x2. Yep. The distance from the point fast and slow meet at the start of the loop x3 plus x3 plus x2. What? It's just the relationship between the distance traveled by fast pointer and the distance traveled by the slow pointer. As fast pointer runs twice the speed of slow pointer, therefore when they meet, distance traveled by fast pointer will be 2x distance traveled by the slow pointer. So fast pointer has traveled start of the loop where fast and slow meet, x2, then x3 plus x2, right, makes sense. x1 plus x2, yep. x1 plus x2 plus x3 plus x2 is equals twice of x1 plus x2. Why is that? Slow pointer moved x1 plus x2 distance. Fast pointer moved twice of that distance. How? Yeah, makes sense because they meet. Yep. Therefore x1 equals x3. x1 equals x3. Makes sense. Just to be sure, we can also watch leetcode's video. Leetcode linked list cycle 2. Or you know what, let's do this question first. Let's take this. So we have a slow pointer and fast pointer here. Okay. Slow moves by 1, fast moves by 2. Slow moves by 1, fast moves by 2. 1, 2. Right? So fast and slow meet at 0. Right. I just need to prove that the distance from fast to the start of the loop is equal to the distance from start of the linked list to the start of the loop. which we have proved over here. I mean, I can take a look at one more most voted image explanation. Right. Okay. This distance is x. Length of fast travel 2x plus y. X plus y, slow traveled x plus y distance, and fast traveled twice of that, correct? Then if we subtract these two, we get length of cycle. How? Yeah, because fast has covered the cycle once and is meeting at slow at some point. So yeah, makes sense. Then x plus y equals the length of cycle. X equals nc minus y, the length of cycle, minus y, which means let slow continue to travel from x plus y, and head travel one step at a time. After x steps, head and slow will meet at the beginning of the cycle. This is way easier to understand. Okay, we can write this first as well. So we have list node slow, which is just head, fast, which is head next, right? If not head or head next equals null pointer, then return. What? Return null. Okay. While fast and fast next, slow equals slow, while slow is not equals fast and fast next. This should be before this condition. Slow equals slow next, fast equals fast next. Now or we can do one more thing here. If not fast or not fast next, then return null pointer, right? Now they both are at equal position, same position. Now I need to either move slow to the head or fast to the head, that doesn't matter. Let's move fast back to head, while slow is not equals fast. Slow equals slow next, fast equals fast next, return slow. Is it TLE? I messed it up, bitch. 3, 2, -4. While slow is not equals fast. Slow equals slow next, fast equals fast next. What? What did I do, brother? What is pause? What the fuck is pause? There is a cycle in a linked list if... What is pause, man? If there is some node in the list. Oh, okay. Position is where is the entry point, right? Yeah, bro. Okay. But why is this TLE? Slow starts at head. Fast starts at head next. While slow is not equals fast, slow equals slow next, fast equals fast next next. We can simulate it again. Slow, fast, next next, right. Slow, fast, next next. Should be here. Then what's the problem? One, two, 1, 2. Oh. Position equals 0. Denote the index of the node that tail's next pointer is connected to. It is -1 if there is no cycle. No, that pause is not passed as a parameter. Okay. Maybe in this it is getting TLE. Let's see. If it is just 1 and 2, slow is here, fast is here. Next, next. Yeah, it should be fucking... Why is this TLE, bro? Oh, we are starting at the same position. But why is that the case? Let's see this guy's solution. While fast next and fast next next. I mean, it should work in both cases. Like, why the fuck is this not working? Okay. While fast and fast next. So what is the time complexity? I believe order of n, order of 2n, because we are traversing the linked list twice. In case there is a circle, yeah, it's order of n. So it's fine. It's all right. Why grind lead code? Bro. CP algorithm tortoise here first link, trust me, good and short explanation. Yeah, I understood. I understood it now. It's clear. It's clear to me. Thanks for that. Why grind lead code? Because I want a new job, probably. That's the main reason, brother. By the way, how are you guys? It's been tough. Okay. Let's get back to this guy. So the problem here is same. Can you give your intro? What the fuck is this intro? What the fuck is an intro, bro? Intro? Like introduction? I am big brain coding. I code. That's your intro. Given an array of integers, nums containing n plus 1. Okay. So the problem here is similar to linked list cycle 2. Now they have already done the trick of you doing n plus 1 integers and the range is 1 to n. So these numbers that are stored in nums are always within index. It won't exceed like 5 or something. So there's a mistake. This is 4 actually. This is also 4. There is only one repeated number. So imagine this as a linked list containing a cycle. How can we imagine that? So 0 is connected to 1, 1 is connected to 3, 3 is connected to 2, 2 is connected to 4, 4 is connected to 2 again. And like, are you a student or maybe looking for a job like that? By the way, new here. Okay, I have a job already. I'm working as a software engineer in a company. I am just looking for a new job. That's why grinding lead code. Yeah. I'm not a student. I passed out in 2021. So I have around 4 years of experience. Yeah, brother. So yeah, this can be represented as this. So we just need to find which number is repeated, which means the entry point of the loop. We can do the same shit as we did in linked list cycle 2. So what do we do here? Slow equals nums of 0. We can even start from 0, right? Let's do this. Fast equals nums of 0, while slow is not equals fast. And there it is guaranteed to have a repeated number, so we don't need to check for end of list or something. While slow not equals fast, slow equals nums of slow, fast equals nums of fast. Now we have reached the starting point. I should actually do this. Now fast equals 0. We do the same loop. Okay, messed up here. Okay. Slow is 0, fast is nums of 0. Slow, fast. Slow, fast. Slow, fast, slow. Yeah. Then fast goes here. Slow moves 1, fast moves 1, slow moves 1 again, fast moves 1, slow move. Okay. So there is a mismatch. Do I need to start both at 0? Yeah, that might be it, man. This might be it. Yeah. Oh, do while loop. Crazy, brother. Yeah. So we can do this shit. Okay, still wrong. While slow is not equals fast, do this. Okay. Slow becomes 0 while slow. Oh. Why did I do this? But yeah, that won't be a problem, brother. Okay. Cool. Next question. LRU cache. Now this is a big one. Design a data structure that follows the constraint of an LRU. What is LRU? Let's take a look. Least recently used. Discards least recently used items first. This algorithm requires keeping track of what was used and when, which is cumbersome. It requires age bits for cache lines and tracks the least recently used cache line based on these age bits. Okay, so if we have this kind of input, LRU cache of size 2, so we simply need to make a linked list of size 2, right? And when we put anything, okay, initially nothing will be there, so we keep track of the size of the linked list in a variable. Initially size is 0, but we know the max size or capacity. Capacity is 2. Now put operation comes and we have a key value pair. Key value pair, right? Get key value. Okay. So we will be putting key in this linked list. Okay. And we can store the key value in a map. So two things will be there, two data structures basically. One will be a hash map storing key value. So when 1 comes, 1 is the key, 1 is the value, and since size is 0 of our LRU cache, we create a node of with 1 in it. 1 represents the key. Now we have a put operation again. Now 2 comes with the value of 2. Now since we have this one already, this won't be the most recently used. This is the latest one. So we put it in front. I did this LRU cache problem few days back. Nice. Yeah, I have also done this before. I'm just trying to remember what was the solution here. Yeah, I've already done this before, but it's been a long time. So almost 2 years, or I don't know, 1 year. Okay, so 2 appears. We push the value to map. We create a new node in front of this, and we say this. We basically say the next node of this is this. So what we need to keep track of here, we need a head pointer and a tail pointer, right? And we increase the size as well. Every time when we do a put operation, we increase the size. Now size and capacity are equal. We can't put any more things in here. Now we get a get operation, right? We have a what? Put 1 put 2 get 1. Now get 1, we can simply return the value by map, but 1 is now used, right? This should be in the front. Basically head represents the most recently used and tail will represent least recently used, right? Which company do you work in? I work at Akamai Technologies. Yeah, it's a CDN security company, CDN and security. So you may have heard of it, Akamai. This one, CDN, cybersecurity and cloud services. I work here. Okay, where were we? Most recently and least recently. Now get is the most recently used here, so we need to move it at the front of the linked list. So now what we need to do is we need to traverse from the start of the linked list, keep track of previous, move until current reaches 1. So current moves here and prev reaches here, right? Then what we need to do, current should be moved to the front of the linked list, right? So only 3 operations will be needed here. Prev next becomes current next, right? So basically we are bypassing this arrow and this will be this. Now current should be moved to the front, so we can simply, okay, previous next is moved, current next should be head, right? Can we simply do this? Current next becomes head and then tail becomes previous and head becomes current. Isn't this all that we need? Let's see it again. Previous next equals current next. Yep. Current next becomes head. So we do this basically. And then tail becomes previous. Yep, because this is the end. No, tail should not be previous. because there can be a node here also. Oh, I messed up. Tail should not be previous, man. If current is tail, then it is a problem, right? So if tail equals current, or what we can do is simply just delete this current, man. Don't even try to move the next pointer of current. Just delete this current. That is way easier. Just delete current, right? That will be very straightforward. So for deleting, we just say previous next equals current next, right? Now if tail was current, right, then tail becomes previous, and that's all. And then delete current, not delete, before deleting get the value and put a node here. Yeah, delete this node and put a fresh node 1 pointing to this, move the head pointer, and that's it. So this is the get operation or put operation if put already exists in the thing, in the cache. Yeah, brother. Okay, let's take a look at the design again. So we need to keep track of size. We know the capacity. Input, when size is less than capacity, we create a node at the front and we push it. In get, we find the node here, we delete it, and then we insert it at the front again. So get operation is the main deal. Okay, so we need int size, int cap, this size equals 0, this cap equals capacity. We can have one private function, void evict least recently used, evict least recently used. What if we do a doubly linked list here? Will that be more efficient? I mean, yeah, evict LRU. Yeah, if we have a doubly linked list, it will be more efficient, right? From tail, we can simply go to the previous node and we can delete tail, right? Yeah, brother. But I forgot how to do doubly linked list in C++. Doubly linked list in CPP. Is there any STL that I can use, or should I create a fucking Did I use a custom node here? Yeah. Okay. Let's create a custom node. Fuck it. So we need struct node it will have a do we need a value here? I don't think so. Yeah, we need a value key, and in node next node prev, right? And we need here head, we need a tail, okay, let's get the easier things first. If size is less than capacity, if size is equals capacity, then do something, basically evict LRU, otherwise create a new node. Oh, we need a fucking constructor. Okay. We create a new node also. I didn't. Okay, unordered map of int. This will be data. Now input operation, if size is equals cap, otherwise if data dot find key is not equals data dot end, then delete the existing node from the linked list, right? Right. And instead of this, if I do this, will that be more efficient? And in node I can even store the fucking value, right? Isn't this way easier? Because I can directly access that node that I want to delete, right? What do you guys think? Basically, instead of key value, this will be key node, and node will store the fucking value and whatever next and previous. Yeah, let's try to implement. I'm just thinking of if there is any catch. I mean, would it fail? Okay, let's see. Fuck it. Okay, if data dot find key is not equals data dot end, then node star current equals data of key, right? Delete this. Harish Dunaga, hi brother. Delete node current. By the way, where do you work at? I work at Akamai Technologies. Yeah. You may have heard of this company. I don't know, brother. but it's a CDN and cybersecurity organization which gives platform as a service, also some software, but mainly infra and platform, two things. Okay, back to the question. If it exists, then delete. Else, if size equals this, evict LRU. Right? Then at this point we are sure that we have enough space in the linked list to put this. So new node is key and value, then new node next equals head prev equals new node, head equals new node. I did on LinkedIn. Oh, LinkedIn connection here. Planning to switch? Yes. Yep. Planning to switch? Yes. I'm just grinding leetcode just to sharpen up my leetcode skills that I lost. Okay. I think put operation seems fine now. I still need to implement these two functions, delete node and evict LRU. But before that, you know what? Let's do this. Okay. Evict least recently used, which means, okay, we forgot one thing, size. Okay. Now size can also be mapped by just this data, right? Delete pair from unordered map CPP. Erase. Okay. Which tech stack do you work on? I work on Java, Spring Boot, and sometimes Python, sometimes shell scripting, and yeah, mainly this. What else? I slightly worked in Angular, but that was a long time ago. But yeah, mainly Java, Spring Boot. That's all. Okay. Now, okay. I forgot to... Okay. If I'm deleting node, then it should delete from the data also, right? Yeah. If data dot size, yeah. Oh, I forgot to fucking data key equals new node. I can do this anywhere, but it, yeah, makes sense. Okay. Let's, okay, evict least recently used, so it is at the tail, right? Maybe I've made this too complicated already. Now the point is, does your company have any SD1 new grad openings? I mean, if you can find it on the careers page, then it exists. Otherwise, I don't think so, brother. But yeah, hiring for new grads is pretty bad right now. Every company needs some experience. I don't know why this trend is happening. But if you can find any opening on the careers page of Akamai, I will definitely refer you. Just drop your resume on LinkedIn messaging. Maybe we are connected. I don't know, brother. Or have you messaged already? Maybe I have not seen that. I'm sorry about that. Okay, let's see. No, I don't think we are connected, brother. Yeah, you can send me a message. If you want to see the profile, yeah, connect with me here. Yeah, I've shared it in the chat. Okay. Now input, there is one more thing to consider. When head and tail both are null pointer. I meant I've seen Akamai on LinkedIn. Yeah, on LinkedIn also they have some listings. If you find for NESD one, yeah, you can drop a message to me. I can refer you for sure, brother. Now here I can check if tail is equals null pointer, then tail equals head. That's all, right? We create a new node. We push this node to data. If head is equals null pointer, then new node next equals null pointer, previous is also null pointer. I mean, it is already assumed that it is null, right? Yeah. So we don't need to do this. We can simply say head equals new node, tail equals new node. Otherwise, do all of this. Okay. Now evict LRU will be easy as 1, 2, 3. We simply need to say node last equals tail, tail equals tail prev, tail next equals null, and last prev also null, delete last. And then there is one more function which is just delete node, and we are given a reference of a node. So simply send connection request. Let me check once. Harish D, night on LeetCode. Mm-hmm. 1600 on Code Chef. Bro, you're good, man. Let's see your project. Your portfolio seems all right. Did you make this from scratch? Featured projects, testimonials, course platform, code crafter. Okay, link to a GitHub repo without a readme. I suggest adding a readme here. I mean, just a description what your project was about, because in one line I can't deduce what is this project about. Do you want me to share your portfolio on stream? I don't know if you're comfortable, but yeah, I'm just looking at your Versal app, that's all. Course platform is also a project which is not deployed. If it is a simple static website, you can deploy that. Let's see, testimonials. Is this deployed? Yeah, this seems deployed. Collect feedback from your customers with ease. Add testimonials for your website with no coding at all. You can share. Okay, let me share, brother. Okay. Hopefully it is on stream now. So what I was suggesting is adding something useful in these readme, like what is this project about? Maybe a sequence diagram or something, a simple flow diagram, what this project does. Same with this. Okay, let's try this. Oh, you have hooked up GitHub and Google login, which is good. I'm not gonna log in though. But yeah, if this works, then it's great. Does it have a backend? I tried deploying it and I got some build errors. It was a long time back. I mean, these are the things that separate you from the crowd, so I suggest focusing on these things. Try debugging those errors and maybe you can deploy again. But yeah, this is all right. This is good. I see your leetcode is pretty good already. Oh, great. Good consistency. Yeah. Yeah, you can send your resume and the job link. I will refer you. No problem, brother. Seems fine, man. It has backend. Good, great. Okay. Yeah, brother. Okay, back to the original question. I was implementing this delete node, right? So if it exists, now if this is head, then we can skip this, right? If current is not head, then delete node. No, we can delete it. Yeah, fuck it. Okay, so simply we need the previous equals node prev. We need the next, which is node next. If prev is okay, we can even check here. If node is head, then head equals head next, head prev equals null pointer, right? Delete node, that's it. Else, if it is not head, it can be tail also, but let's see. Node prev equals node prev node next equals next. Oh, I can do one thing here. Else if node is tail, then evict least recently used. Easy. And when we are evicting this, we also need to erase from data. So before deleting, I can do data.erase last key. Same as here, data.erase node key. Yeah, brother. Else we get the previous next. We say previous next prev node, just to avoid confusion. Prev node next equals next node. Next node. For the linked list problem, we can create a dummy node and make it as head. That way it is easier to remove head. Yeah, that's also one way. But I'm just trying new things, man. We can always go for the most obvious solution. But yeah, just trying, just coding, vibe coding, you know. Okay, then we say data.erase node key. Delete node, right? Hopefully. Let's see if we have cooked or not. So get, okay, int value equals data key value. Is it val or value? It is val. I will check if there are any openings and will let you know, bro, tomorrow. Sure, man. That's fine. And I have accepted your connection request, so yeah, you can message me anytime, brother. Okay, bye, brother, bye. Good luck. Okay, so I was on get. I get the value. I delete data key, and then I put key val, return val. No member name size in this cache. Okay. Cap. Cool. Okay, evict least recently used tail equals tail prof. Evict least recently used. What? Okay, tail pref. Okay, put 1 1, put 2 2. Now get 1, right? Tail should be 1. Okay, let's see. When I'm doing a put here, when head is null pointer, head becomes new node, tail also becomes new node. Else uh, else new node next equals head, head previous equals new node, head equals new node, tail new node. Okay, let's see. Put key value, cout get key. Get 1 1, put 1 1. Okay, so on put 1 1 we have something wrong. What? Oh, okay. So when we are getting, we get the value, then we delete that. Delete node. If if node is head, damn bro is grinding, bro. Okay, what's the matter here? Get 1, get the value, delete the node, delete data key. If data dot find key is equals data dot end, return -1. Put key value. So in put we are putting 1 1. Data dot find key doesn't exist. Data size is also bad. Data size is equals cap. Data dot size. Okay, put 1 1. Oh, is it this? Fuck, man. Delete and delete node. Bad naming convention. Bad naming convention. fucking up the question. Okay, still bad. You know what? Let's look at my previous solution and fuck it. So node contains previous, next, value and key. Yeah. Now in this we have capacity, head to head, tail and map, correct? Capacity equals capacity. Head and tail have dummy nodes. So it makes easier. Okay, so this guy was correct. So head and tail are dummy nodes. So when we do a get, if it is not there, return -1. If found, remove and insert. Oh, yeah, brother. Yeah, makes sense, brother. Yeah, this is way easier. Let's make these changes. Okay. This is a lesson that if something is getting way too complicated, it's wrong. So these two functions are not required. We simply need void insert a node and remove a node. And in the constructor, we can simply say this is a new node -1 new node. Cool. Found equals data key, remove found, what? So in get, what we are doing, remove found and insert found. So remove doesn't delete that node actually. It just removes that node from, now what? It just removes, extracts it from the list, and that's all. It doesn't free its memory. And insert is simply insert, it's done. Yeah, makes sense. Makes sense, brother. Remove found and insert found. Return found val. And input, we don't need this shebang. Let's fucking, so insert a node, which means the head next, why am I creating a new node in insert? Why is that the case? No, it's just first. Okay, I can do node next equals head next, head next previous. Okay, makes sense to do this. First node in the linked list, node next is first prev is node, they are connected, right? and then head next is node. That's all. Node prev is head. Attach to list, attach to head. Yeah, bro. Node prev is head, head next is node. Yep. And in remove, we simply say left equals node prev, right equals node next, right, left next equals right, right, prev equals left. That's all. Then in get, we do found. We don't need this. Then in put, we check if data dot find key is not equals data dot end, which means it exists in our LRU cache. So we say remove data key and delete data key, right? Data dot erase key. Data dot erase key. In remove, we are just removing that node. So input, if it exists, we can do that. Otherwise, let's call it fresh new node key value, right? Data of key equals fresh, insert fresh. If data size becomes this dot capacity, then remove tail. Tail prev. Okay, there's a memory leak here because in this, okay, LRU equals tail prev, remove LRU and free this memory, free, insert fresh data key fresh, data dot erase key, fresh new node. This is it enough? Okay, still bad. First prev equals node. Oh, first prev equals node. Node next equals first. Access within null pointer of node. First prev. First prev. First. Head next. What? Okay. This head next equals tail. This tail next equals head. Okay, still in remove we are getting node previous, right? Node next. Okay, node prev. Okay, we are messing up something in here probably. Head next. Node next equals first. First prev equals node prev equals head. Head next equals node. Okay. T, insert T, first head next. T next equals first, T prev equals node, T, what? Yeah, first prev equals tree. Node prev equals head, head next equals T. Yeah, makes sense. So this is good. Then in remove, we are doing node prev, T next, left next equals right, right prev equals left, correct. Then what are we doing? Head next equals tail, tail next equals tail, prev equals head. Prev. Am I this bad, bro? Okay, still bad. If data is not found, then do this, 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 and input. If it is remove, okay, we are not data dot erase key. Why aren't we doing that? Fresh equals new node this, insert this, and data key equals fresh. Oh, if it is greater than this, remove this, data dot erase LRU key, delete LRU. Few things. I will do this question tomorrow again, just to be sure. Yeah, it's all right. Okay, I will not be taking off. I'll do this again tomorrow. Merge k sorted linked list. Okay, I think this might be the last question of today. You are given an array of k linked lists. Each linked list is sorted in ascending order. Merge all the linked list into one sorted linked list and return it. Okay, let's see. Let me check one thing again. Okay. Okay. So we have 3 linked lists right over here. 1, 4, 5. Then we have 1, 3, 4. Then we have 2, 6. Merging them into one sorted linked list, and I believe we don't need to use extra space. Yeah, that will be the trick, guys. So what do we need? We need to keep track of the head of each linked list. Let's call them h1, h2 and h3. Then we get the minimum value head. and let's keep one more node, which will be okay, let's create a result node with a dummy value, dummy node, right? Right. Let's, and then create a copy of this current. Okay. What we need to do here is get the minimum value from these nodes. Since h1 and h2 are equal, let's see, like h1 is the minimum, we can assume anything since they are equal. So now h1 is the minimum, then current next will be h1, right? And then current equals current next, h1 equals h1 next. Then we get the next minimum, and in this way we can simply merge epic. Let's do that. Okay, so vector of, oh, we already have this thing, so yeah, brother. Let's create a result node. Res equals new list node. Value can be anything. Yeah. List node current equals res. Now, okay, I can do while true. For list node head in lists, if h is null pointer, then continue. Otherwise I need to get the minimum node, so int min value, int max, if int min, no, int max, next node equals min node. If h value is less than next node value, then next node equals h, right? And then at the end we can check if next node val is int max, then break. Otherwise current next equals next node, current equals current next, next node equals next node next. Is it TLE, brother? Yeah. Now we messed up somewhere. Res is -1, current equals res, min node equals this. Then we say next node equals min node. Then we go to each head of the list. If it is null pointer, then continue. Otherwise, if the value of that node is less than the next node value, Then we say next node is h. If next node value remains int max, then break. Or I should do if next node is min node, then break. Right? Otherwise, current next equals next node. Current equals current next. Next node equals next node next. Instead of naming it as next node, let's name it min head. Min head. Min head. Min head. Min head. Okay. Then why is this time limit exceeded? Just 1 1 1 1 1. What? Yeah, min head equals min head next. Why isn't this moving, brother? Min head equals min head next, bro. What? Min head equals min head next. Why isn't this working? Huh? H val is less than min head val. Min head equals h. I'm storing that node value, right? And when I'm moving it, it should move. Why isn't this moving? Fuck, bruh. That's crazy. Let's look at my previous solution. Compare val. What? If lists.empty. Oh, we are keeping a priority queue. But why? I mean, yeah, we can do that. We are pushing every head to there. List node dummy equals this, p1 equals dummy, while min heap dot empty. Okay. Current next equals min head. Current equals current next. Current min p1 next equals current. P1 equals p1 next. Same shit. Why can't we simply use this? I mean, yeah, I see a problem here. When current next becomes min head and I move current to current next, so current and min head are same essentially, right? What? How to store a reference of a pointer in CPP? Yeah, that's what I want to do, man. Ref pointer. Hmm. Hmm. What? What, brother? Okay. Now this is empty. Okay, just one. What? Okay, I have a pointer. Is it this? Is it this, bro? Fuck. Is it this, bro? Still wrong. Oh, fuck. Min head val is. Oh. No, 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 no. Okay, bro. Shit. Instead of this, let's do min value. If hval is less than min value, fuck, bruh. You know what? Fuck it. Let's do PQ solution. This is just cringe. So we need a priority pq of list node, vector of list node, compare value pq for list node head in lists. What? pq dot push head, right, while pq is not empty, list node current equals pq dot pop. Oh, sorry, pq dot, is it peak? pq dot top, pq dot pop. um hmm. Now this compare value, I know how to do that. Struct compare value, bool operator, const list node a, const list node b, const expr no except should be this. What? Okay. Cool. Yeah, this was the solution, guys, for this thing. And yeah, I'll end the stream now. It's been a while. I'll be back tomorrow with next set of questions. Until then, GG's, have a good day or rest of the night, and I'll see you again. Cool.